Hello, boys and girls. Let's take a look at converting fractions to decimals, decimals to fractions, those tricky repeating decimals to fractions, and we're going to have a little blast from the past, finding square roots and estimating square roots to the nearest tenth. Let's take a look at tonight's homework now. Let's take a look at our homework, and we'll start with number 1. Number 1 is 0 and 2/25ths. And we are to convert that to a fraction. Well, all you have to do is read the decimal properly, and we'll know that that is 25 hundredths. And we can reduce this. We can factor we can factor 25 out of both of these. 25 will go into 25 once, and 25 will go into 100 4 times. So we have 1/4. That's our final answer. Let's take a look at number 2. Now number 2 is a repeating decimal, so it's not quite that simple. This is not 2/10ths. It is 2/10ths plus 2/100ths plus, and on it goes. We know that this is really, 0.2222222, and it just keeps on going. Okay, so what do? We have to use an equation. First thing we want to do is we want to put this ever-growing repeating fraction in a box, and that box we're going to call x. Got to contain it. Okay, so we have 2/10ths as a repeating decimal. The next thing we want to do is you want to ask yourselves, well, if we were to make this 2/10ths repeating decimal a mixed number, what would we have to multiply it by? And we would have to multiply it by 10 to get that decimal to move over 1, and that would give us then, if we were to do that, that would give us 2 and 2/10ths repeating decimal. So, and that's not what we're doing yet, but we're going to do that. And how would we do that? We need to multiply it by 10. So we take 10x, and that would be equal to 2 and 2/10ths repeating decimal. Now, it'd be really nice if we could just get rid of this repeating decimal. Okay, then we could work with it as a fraction, and that's what we're going to do. What we need to do is we need to get rid of the 2/10ths repeating decimal, which we've already established, and we've called it x. So let's take it away, not from just one side, but from both sides, since we are working with an equation. See, I'm taking away x from this side, and I'm also taking x away, which is equal to 2/10ths repeating decimal. What that's going to do is that will cancel out. It'll cancel out a repeating decimal, and I'm left with 10x minus x, which will be 9x, is equal to 2. Okay, I can now see the light at the end of the tunnel. Now I just want to isolate x, get x all by itself, and I have to perform the inverse operation. How do I get rid of the 9 times x? Well, I have to divide it by 9. Okay, that'll get rid of the 9. I'll be left with x, and what I do to one side of the equation I must do to the other side, and I'll be left with x is equal to 2/9. And there we have it. Boys and girls, now let's switch gears, and let's go from we're going to go from fractions to decimals. Okay, we know that every fraction is really a division problem, and the answer to that division problem is a decimal. Now, when we have a mixed number, don't let that throw you off track. Once again, we're just going to focus. We're going to focus on the fraction part. We'll come back. We're not throwing away the whole number, but after all, if you read this number properly, it's 7 and 2/3, or 7 plus 2/3. So if we figure out what the 2/3 is as a decimal, we can just add it back onto the 7, and we'll have our correct answer. So we know that 2/3 is really 2 divided by 3. 3 will not go into 2, but it will go into 20. So we're going to treat it like 20. It's still 2. It's 2 and 0/10ths. But 3 goes into 20 6 times. 6 times 3 is 18. We subtract, we get 2. And I know what you should be seeing a pattern. There we have it. Okay, it's going to continue to be 0.666. It's just going to keep repeating. So we have 6/10ths repeating decimal. Therefore, I can take this and add 7 to it, and that's going to give me 7 and 6/10ths repeating decimal. Okay? 2/3 is the same thing as 6/10 repeating decimal because I took 2 divided by 3, and that was my answer. I took my whole number 7, added it back onto this equivalency, which will give me 7.6. Now this one doesn't look as fun, but it's not really that difficult. We have 277/500ths. Once again, we take our numerator, our first number, 277, and we have to divide it by 500. 500 will not go into 277, but it will go into 2,770. So I know that 5,000 will go into 1,000 twice. It'll go into 2,000 two more times. I'm up to 4, and then 500 will go into, so we're going to do 5, which will give me 2,500. I subtract 0, 7, and then I get 7 minus 5 is 2. They cancel each other out. I bring another 0 down, and 500 will go into 2,700 5 more times. I get 2,500, and when I subtract, I'm going to get a remainder of 200, and then I bring down another 0. I think I'm going to figure this out pretty quickly. 5 goes into 2,000 exactly 4 times. And my final answer is equal to 554 thousandths. Let's go back to Unit 1 and review how to estimate the square root of numbers that aren't perfect squares. For example, number 17 here, we have the square root of 101. Now I know that 101 is not a perfect square, but it is very close to the perfect square of 100, so I know it's somewhere between the square root of 100 and the square root of 121. Now the square root of 100 would be 10. The square root of 121 would be 11. Therefore, the square root of 101 must be greater than 10 but less than 11. It has to be somewhere in the middle. And it's definitely closer to 10 because when I compare the square root of 101 and the square root of 100, they're only 1 apart. Okay, so I know it's going to be 10 point something. So the first step to find our something, our decimal part of the answer, our fractional part of the answer, is to take the difference between our first two squares, 101 and 100, and divide that by the difference between our second two square roots, which would be 121 minus 101. And I'm going to get 1/20. Technically, my answer, my exact answer, the square root of 101 is 10 and 1/20. But let's change this 1/20 to a decimal since we need some practice with that anyway. I'm going to take 1 and divide it by 20. 20 will not go into 10, in fact, but it will go into 100 5 times. 5 times 20 is 100. We have no remainder, we can stop. So I take my whole number, 10, and add it on to my decimal answer, and that will give me the answer of 10 and 5/100ths. That is the square root of 101. We were supposed to estimate to the nearest tenth, but we can find the exact answer for that. It's good practice. Number 19, we need to find the square root of 72. I know that that's between the square root of 64 and the square root of 81. After all, 72 falls between the perfect squares of 64 and 81. I know that the square root of 64 is 8. The square root of 81 is 9. Therefore, this square root must be greater than 8 but less than 9. And 64 is a little closer to 72. Therefore, it's going to be closer to 8 than it is to 9. So once again, I need to find that decimal part. I know it's going to be 8 and something, so I need to find the difference between 72 and 64, the difference between my first two square roots, and divide that by the difference in my second two square roots, which would be the square root of 81 and the square root of 72. When I go to subtract, I'm going to find out that I get 8 over 9, 8/9. So what do I do with this? I take 8 and divide it by 9. 9 will not go into 8, but it will go into 80 8 times. 8 times 9 is 72. I subtract and get an 8. I bring another 0 down. I get 80. Hey, I see that there's going to be a repeating decimal here. So I can say, and I need to add my whole number to that, I can say that the square root of 72 is approximately 8 and 8/10, which is a repeating decimal. Now let's find the square root of some fractions. Now, I would suggest to you, you could actually treat the fraction as a division problem, divide through, and then find the square root of that quotient. But I know that the square root of 9/49 is the same thing as the square root of 9 over the square root of 49, which to me is just a lot simpler. So the square root of 9 is 3, the square root of 49 is 9. Whoops, well that's not my final answer. I can actually reduce that to 1/3. Over here, same thing. I know that the square root of 81 over 144ths is really the square root of 81 over the square root of 144. I know my perfect squares. The square root of 81 is 9. The square root of 144 is 12. I can reduce this. 3 goes into 9 3 times, and 3 goes into 12 4 times. So I get 3/4 as my final answer. Boys and girls, let's take a look at some classic tax tip and discount prices. Basically, if there's any type of markup, we need to find the percentage of something and add that to the original price. And if there's a discount, that means we are finding what the discount of the original price is, and we're doing the opposite, we're taking it away. So for here, number 25, if you look, it says the original price of a camera is $629.99, and there's a 55% discount. So what does that mean? Well, first of all, we know that we're going to be taking 55% of this price away. Now, when you hear the word of, or even the word of is implied, mathematically we know we're multiplying. Another important thing to realize too, that 55% means out of 100. So 55 out of 100 is the same thing as 55 hundredths. Okay, so I'm going to just get rid of that percent sign there, and now it's an equivalent, but it's a decimal. And now I multiply away. 5 times 9 is 45, carry the 4. 5 times 9 is 45, plus the 4 is 49. 5 times 9 again is 45, plus the 4 is 49. Carry the 4. 5 times 2 is 10, plus the 4 is 14. And then 5 times 6 is 30, plus the 1 is 31. I'm going to put a 0 as a placeholder here. Now I use this 5. 5 times 9 is 45. Carry the 4. 5 times 9 is 45 plus the 4 is 49. Carry the 4. 5 times 9 is 45 plus the 4 is 49 again. Carry the 4. 5 times 2 is 10 plus the 4 is 14. Carry the 1. 5 times 6 is 30 plus the 1 is 31. We add the 5 and 0, we get 5, 9 and 4, we get 14, carry the 1, and then we get 1 and 9 is 10, plus the 9 is 19, carry the 1. 1 and 4 is 5, and 5 and 9 is 14, carry the 1. 1 and 1 is 2, plus 4 is 6, 4 and 1 is, 3 and and 1 is 4, and bring the 3 down. I have 1, 2, 3, 4, 4 decimal places in my problem, in my multiplication problem, so I need to have 1, 2, 3, 4 decimal places in my answer. And I should round this 346 and 49 hundredths to, well, we can keep it right at 49 cents because this 4 will not affect the 9 at all in this digit. So we're just going to say it's approximately $346.49. That is our discount. But our final price, we got to take this away. To find our final price, we have to take the original price, which is $629.99 minus, this is our original, minus our discount, which is $346.49. That's our discount. That's what we take away. 9 minus 9 is 0. 9 minus 4 is 5. 9 minus 6 is 3. 2 minus 4 can't do it. Got to borrow from the 6. This becomes a 12. This becomes a 5. Now 12 minus 4 is 8. 5 minus 3 is 2. And that gives us $283.50. This is our sale price or final price. Let's take a look at number 31. This time we have a puppy. That's $365, and there's a 4% sales tax. Okay, so the first thing we need to figure out is what the tax is. We know that it is 4% of 365, so once again we're multiplying. And we know that 4% really means 4 out of 100, which would be 4 hundredths. So I'm going to get rid of the percent and change it to 4 hundredths, which is the same thing as 4 out of 100, or 4%. Okay, let's fire away here. We're going to take 4 times 0 and get 0, 4 times 0 and get 0, 4 times 5, get 20, put the 0 there, carry the 2 up here. 4 times 6 is 24, plus the 2 is 26, carry the 2. 4 times 3 is 12, plus the 2 is 14. Okay, and I don't need to multiply 0 times all this. I know it's going to be 0. But I do need to go back and find out how many decimal places I have. And I have 1, 2, 3, 4. So if I have 4 decimal places in my multiplication problem, I need to have 1, 2, 3, 4 decimal places in my final answer, my product. So the tax, the amount of tax that we're going to have to pay is $14.60. Okay, that's our tax. Now tax, we add, okay? Tax makes us, discounts make us happy. Yes, happy. Discounts make us happy because the price goes down. Tax makes us sad because the price goes up. So at least makes the government happy, I guess. But anyway, so I take my original price, which is $365. And I have to add my tax of $14.60. Okay, so this is the original price. This is the tax that I have to pay in addition. And when I add these two together, I get my final price. Zero, let me put my decimal point right there. 0 and 0 is 0. 0 and 6 is 6. 5 and 4 is 9. 6 and 1 is 7. So the final cost of the puppy, with tax included, will be $379.60. Well, boys and girls, I hope that was helpful. If you have any questions about last night's homework, make sure you bring them to class tomorrow. I'll see you then. Bye-bye.